In this class, I will show you how you can draw the structure of sulfate ion. Basically, Lewis structure of sulfate ion. So, Lewis structure is only applicable for covalent and coordinate covalent compound, cation or anion. For sulfate ion, first we have to calculate the total number of valence electrons. Valence electrons are the outermost electrons in the atomic orbital. So, for sulfur atom, the number of valence electron is 6. We can see here 6. Similarly, for oxygen atom, the number of valence electrons are 6. As there are 4 oxygen atoms in this ion, so it will be multiplied with 6 and 6 into 4. There are 2 negative charges in this ion and it is added here. So the total number of valence electron is 6 plus 6 into 4 plus 2 equal to 32. Next, we have to calculate the central, we have to identify the central atom, where central atom is sulfur. As sulfur is least electronegative element between oxygen and sulfur, so it will act as a central atom. So then we will arrange the 4 oxygen atoms as your wish or as my wish. Then make a single bond between oxygen and sulfur atom. Here, here, here and here. In each bond there are 2 electrons. So out of 32 electrons, 8 electrons are used in here and 24 electrons are remaining. The remaining electrons are placed on the outer oxygen atoms to fulfill their octet. So here 1, 2, 3, 4, 5, 6, and there are 2 electrons in this bonding. So total 8 electrons which follow the octet rule. Similarly for this oxygen and this oxygen. So each oxygens in this ion follow the octet rule. And also sulfur follow the octet rule here. 2 plus 2 plus 2 plus 2. So 4 bonding and 8 electrons. So it also follows the octet rule. Now we have to make sure this is the perfect structure of sulfate ion. Let's try to calculate formal charge. There are 4 oxygen atoms in here, and for 4 oxygen atoms, if we calculate the formal charge equal to valence electron minus lone pair or non-bonding electrons minus bonding electron divided by 2. So there are 6 electrons, valence electrons in oxygen atoms. If we see the lone pair of electrons or non-bonding electrons of oxygen, there are 1, 2, 3, 4, 5, 6 electrons. So lone pair or non-bonding electrons are 6 minus in each bond there are 2 electrons. So 6 minus 6 minus 2 divided by 2 equal to minus 1. So for each oxygen gain the formal charge minus 1. For sulfur atom, the formal charge is 6, as there are 6 valence electrons in the outer shell of sulfur. So there are 6 electrons, which is valence electrons minus. As there are no lone pair of electrons or non-bonding electrons in here, we can see there are no lone pair or non-bonding electrons are in here. So the number of lone pair of or non-bonding electrons are 0. Minus, there are 4 bonds are present here, and 4 bonds comprises of 8 electrons. So 8 by 8 equal to 4. 8 by 2 equal to 4. So 6 minus 0 minus 4 equal to plus 2. So the formal charge of sulfur is plus 2. So is this the structure of sulfate ion? Oh, this is unhappy. No, it is not the structure of sulfate because the formal charges, because we can explain by two these points. One, there is a possibility for sulfur atoms for octet expansion. We know sulfur has d orbitals, and which elements has d orbitals can expand their octet. So as there is a possibility for sulfur atom for octet expansion, so this is not the perfect structure. Number two, there is another approach for formal charge calculation where the formal charge of sulfur atom or oxygen atoms might be or may be zero. So let's try another one. We can see here the another structure of sulfate. We withdraw two electrons from these oxygen atoms from here to here and make a bond between sulfur and oxygen. Here another electron pair is withdrawn and make a bond between sulfur and oxygen. So oxygen has now 8 electrons. This oxygen also has 8 electrons. And these oxygens also have 8 electrons. But sulfur has 2, 4, 6, 8, 10, and 12 electrons in bonding. There are no non-bonding or lone pair of electrons are here. So now we calculate the formal charge of sulfur. So there are 6 valence electrons in sulfur minus, there are no lone pair or non-bonding electrons, so it is 0, minus, there are 12 bonding electrons for sulfur divided by 2, and this 2 is from the formula of formal charge. And after calculating the formal charge, we get 0. So the formal charge of sulfur is 0. For double bonded oxygen atoms, this one and this one, the number of valence electrons are 6 minus, there are 4 lone pair, there are 4 non-bonding electrons. So this is 4 minus 2 bond comprises 4 bonding electrons. So 4 divided by 2 equal to R. The ultimate calculation is 0. And for single bonded oxygen atoms, this is minus 1. So now sulfur and two double bonded oxygen atoms have formal charges 0, and another two oxygen atoms have formal charges minus 1. As you know, for perfect structure of any anion or cation or for compound, formal charge have to be 0 or closer to 0. So this is the perfect structure of sulfate ion, and we can write the actual Lewis structure is as follow. So this one has formal charge minus 1, this oxygen has formal charge minus 1, this has 0, sulfur has 0, and this oxygen has 0. So we can draw the structure of sulfate, this or this. And now this is happy. Thank you so much.